equals 1. So we see right from the bat, this thing kind of changes its format a fair bit in these two, right? It's totally different in these two. So before we even really start looking for patterns, we want to get everybody into the same format, because that'll just make it easier to see patterns. So how can we get them in the same format? We first certainly need to have them as fractions. So as fractions, we've got 1. We can always divide by 1, so 1 over 1. Then 3 over 1, and then 3 squared over 2, 3 cubed over 6, 3 to the 4th over 24, 3 to the 5th over 120. First thing we're probably noticing is, hey, we've got 3 to the 5th, 3 to the 4th, 3 cubed, 3 squared, 3. Well, we could write this as 3 to the 1. How can we write 1 out? Well, remember, 3 to the 0 equals 1. Any number raised to the 0 comes out to be 1. So we could rewrite the top as 3 to the 0 over 1. 3 to the 1 over 1. 3 squared over, 2. 3 cubed over 6. 3 to the 4th over 24. 3 to the 5th over 120, and so on. So at the top part, we now see pretty clearly there is a pattern, right? It's the number increases by 1 each time for the exponent on the 3. It starts at 0, so it'll be 3 to the n minus 1. But what about this bottom part, right? 120, 24, 6, 2, and then we got 1 and 1 here. So 1, 1, 2, 6, 24, 120. Well, if we work backwards, we might realize 2, 6, 24, 120, you might recognize, oh yeah, factorials. Remember we talked about factorials earlier in the lesson. That looks like factorials. So 5 times 4 times 3 times 2 times 1 is 120. 4 times 3 times 2 times 1, that's 24. So we have 5 factorial on the far right. So we can write this as 3 to the 5th over 5 factorial. And we'll keep going. So let's work backwards. 3 to the 4th over 4 factorial. 3 cubed over 3 factorial. 3 squared over 2 factorial. 3 to the 1 over 1 factorial would just get us 1. And here's the most confusing part of all. 3 to the 0 over, well, what can we do that will wind up having factorials involved and still get us 1? Now we have to go back and remember there's a very specific thing about factorials. The way factorials work is 0 factorial is just defined to equal 1. So that means we could also write this as 0 factorial. So we've maintained a pattern, right? We're going to wind up seeing patterns because all these problems are going to be based on patterns. So we know that a factorial pattern, it's no surprise it's going to keep going. So we've got on the bottom 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial. On the top 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4, 3 to the 5. So let's compare that to the numbers n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, n equals 6, right? Our first location, our second location, third location, etc. So with that in mind, we see that the top number, the top exponent, I should say, the top exponent is always equal to the value of the location, right? At n equals 5, we get a 4 exponent. So it's always minus 1. Similarly, the 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, it's always that number, it's always the number of the location minus 1 to get to the number in the factorial, right? In the third location at n equals 3, it's a 2 factorial, 3 minus 1. In the sixth location, it's a 5 factorial, 6 minus 1. So we see that they're both based off of this n minus 1 business. So that means we can finally set our an equals, it's 3 to the n minus 1 over n minus 1 quantity factorial. And there's our answer. There's the general term, and it's always, always a good idea to check your work with this sort of thing. So let's just do a quick check to make sure that this winds up coming out. So at A1, we would have 3 to the 1 minus 1 over 1 minus 1 factorial. So that's 3 to the 0 over 0 factorial. So we get 1 over 1, which equals 1, which checks out with what we initially had. Let's try jumping forward to a slightly larger number so we can check against something else. So at A4, we would be at 3 to the 4 minus 1 over 4 minus 1 factorial. So we have 3 to the 3 over 3 factorial. Everything is in this 3 to the 3, so we don't have to simplify that to 27. We can just leave it as it is. 3 to the 3, 3 factorial comes out to be 3 times 2 times 1, or 6. So 3 to the 3 over 6 is what we have for our fourth location. 1, 2, 3, fourth location, 3 to the 3 over 6. So that winds up checking out. We wind up seeing, yay, our general term makes sense. All right, so we've got a really good understanding of how sequences work, how we can get general terms, nth term formulas from looking at them for a while. Recognizing patterns is a really useful skill. It'll show up in a whole bunch of different things in math. So even if you wind up thinking that this is a little bit difficult now, trust me, it's going to wind up paying dividends down the road. You're going to wind up using this stuff a lot, finding patterns in a variety of stuff, whether it's in science class, whether it's in math class, economics, whatever you wind up studying, you're going to wind up having to find patterns of some sort. Even in English, patterns are really important things, right? If we're going to talk about themes in a book, so patterns really matter. So this sort of stuff, really important. We've got a good understanding for sequences. Now we're ready for the rest of this section. We'll have a whole bunch of ideas working from this base of sequences. All right, we'll see you at Educator.com later. Bye.